Welcome and settle in. Imagine yourself drifting just above the quiet edge of night, where the curve of Earth softens into a gentle blue, and a small, aging satellite glides in an orbit it has kept for years. It has no noise you can hear, only the imagined hush of space and the soft tick of systems counting seconds in a language of electrons and light. Let your shoulders relax as you picture that distant traveler moving with steady patience, far from the rush of busy streets and ringing phones. If you enjoy this kind of slow, sleepy science, you can gently tap like and subscribe. And if you wish, use the playlist link in the description to keep learning while you drift off. How sleepy are you on a scale of 1 to 10? Now, rest with that image for a moment, the satellite gliding as if nestled on a smooth ribbon around the planet. It is not new. Its paint, once bright and eager, is scuffed by sunlight and years of tiny invisible particles. It carries a story in its panels and hinges, in the quiet timing loops of its onboard computer, in the memory of every burn it has performed. Imagine yourself hovering just a few meters away, feeling a gentle awareness of its presence, as if you could sense the warmth on its sunlit surfaces and the coolness on the sick that turn toward the soft darkness. The gentle rhythm continues, unhurried and calm. The satellite began with a promise. It was designed at long tables with clean white paper and later in glowing diagrams on office screens where engineers moved their cursors slowly, placing lines and measures with an almost meditative care. Each component was thought about, weighed, and measured. Aluminum honeycomb panels, lighter than your expectations might allow, were chosen for strength without burden. Blankets of thin, crinkled foil would keep warmth in and reflect harsh heat away. Solar arrays would unfold like a patient breath, stretching their dark blue cells toward a star that has always risen. In your mind, you can trace a fingertip along the panel edges, feeling the imaginary texture of their microscopic ridges, hearing in your ears the soft memory of a clean room's filtered air. The gentle rhythm continues. Inside behind the panels and brackets are the quiet organs of the spacecraft. Batteries rest like well-trained hearts, charged and discharged countless times by the day-night rhythm of orbit. There are gyros and reaction wheels that spin like tiny tops, so smooth that the motion is almost like stillness. There are thrusters that speak in brief whispers of propellant, correcting the aim of dish and bus when the geometry of Earth and Sun slowly changes. There is a computer, reserved and modest in its power by the standards of your phone, but steady and hardened, content not to dazzle, but to endure. Imagine yourself listening for a hum that is almost silent, a suggestion of movement inside a protective shell, where the vacuum presses with a pressure that is the absence of pressure. The gentle rhythm continues. Long ago, the satellite who left Earth's surface in one firm push. That story was brief and bright, a column of flame and a rattling that you would have felt in your chest more than heard in your ears if you had been near. But we will pass over that bright moment quickly, like a person turning a page with a light touch, preferring the quiet chapters that followed. After the ascent, there came a calm coast, a gentle arc where thin sunlight washed over insulation blankets, and the first helium-chilled breaths of space seeped into every crevice. Then a burn, then two, then perhaps three patient adjustments that drew the satellite from a transfer path into the circle it was meant to keep. Ground antennas listened, slow and careful, like gardeners watching a delicate sprout find its path toward the light. In its early days, the satellite solar arrays were a little like fresh leaves, crisp and responsive, converting sunlight with eager efficiency. Under that light, batteries filled with charge, and the little motors that trimmed antenna pointing answered each whispered command from the ground with the confidence of youth. The onboard clock, a quartz heart or perhaps a more precise oscillator, kept time in small, assured beats. Signal paths were clean, thermal blankets were unwrinkled, lubricants and bearings were still in their original places, nothing yet lost to the long breath of vacuum. If you were floating near then, you would have noticed the sharp edges of everything, the newness that glows even in machines. But as time passed, edges softened in the mind, even if the metal remained the same. The gentle rhythm continues. Orbit is a steady cradle. The satellite falls around Earth at the same rate Earth curves away beneath it, a graceful compromise that feels like rest. With each hour, geography slides by. If it is a geostationary satellite, it holds itself fixed above a particular longitude far over the equator, and the world below turns like a patient carousel. If it is in a different orbit, perhaps lower, it passes over snow-lit mountains and velvety night seas, over pale deserts and green deltas, over chains of small islands where evening fires flicker at the edge of the tide. In all cases, the satellite knows only two scenes, both of them gentle. One is sunlight, a clear, steady bathing in photons with no air to scatter them, and the other is shadow, the smooth coolness of eclipse, when Earth slips across the sun and the satellite moves into darkness that is clean and simple. Imagine yourself watching that transition, the border between day and night, sliding across the satellite surfaces like a slow, quiet wave. During sunlight, there is a faint warming sound you can almost hear only in your thoughts, the soft expanding of materials, the comfortable stretch of bolts and brackets as they take on a little more heat. In shadow, there is an equal and opposite comfort as they exhale that warmth into the blackness. The batteries, buffers of night, serve their purpose with almost maternal calm, giving only as much as is needed, keeping the satellite's heart beating while stars look on with impartial patience. Temperature sensors report values, currents adjust, small heaters click on with the silent intention, then off again. The telemetry is composed like a lullaby, gentle digits rising and falling within their expected ranges. On the ground, there is a different quiet. In a dimly lit room with screens arranged like a constellation, people sit in comfortable chairs and speak softly when they need to speak at all. They watch signal strength and timing. They review schedules for station-keeping maneuvers, for momentum dumps, for periodic calibrations. The air smells faintly of coffee and settled electronics, a trace of warm dust on power supplies. The voices are calm, the cadence unhurried. Antenna motors outside sweep at glacial rates, tracking as though the satellite were a mildly absent-minded friend who never strays far. The ground system pings, the satellite replies, and the loop is closed. Each pass through that loop is modest, and yet each pass is a proof of connection. The gentle rhythm continues. Time is a slow teacher. With years, the solar cells lose a little of their spark. Radiation in the belts knocks atoms askew, and the neat pathways that moved electrons start to resemble paths through a garden. where many feet have passed. Power margins shrink like the hem of an old coat. The batteries, too, remember each charge and discharge, and their chemistry changes in quiet ways. Small differences measured in internal resistance and in the shape of their voltage curves. These are not failures, only the normal drift of life in space. The same way stones on a beach grow rounder with each season. The satellite responds to each change by simplifying its expectations. It trims heaters. It eases back on non-essential tasks. It reassigns loads to the times when sunlight is most generous. The gentle rhythm continues. Reaction wheels have their own stories. They spin day after day, storing and shedding angular momentum like careful accountants. Space is never perfectly empty, and even the steady pressure of sunlight nudges the satellite in minute and persistent ways. Over time, those wheels gather up that nudge until they near their limits. Then, in a planned moment, the satellite uses a whisper of propellant to release that stored push, and the wheels breathe out, slowing again into comfortable ranges. This momentum management repeats almost like a meditation routine, an exercise that prevents strain repeated with mindful timing. As the years pass, bearings wear. Some wheels grow rough or their controllers grow cautious. One wheel may be switched off while others take up the work. Such adjustments are small, and each one is done with kindness, easing stress, extending the life of a trusted machine. Radiation brushes the satellite in other ways. Charged particles slip through logic gates and deposit tiny bursts of energy where silence is expected. A register flips a bit from 0 to 1 or 1 to 0, and the software notices and gently corrects, as if picking up a small cushion that fell from a chair and setting it back in place. Error correction codes fold themselves around data words like blankets around a sleeping child, catching single events and smoothing them away. Occasionally, a bigger disturbance arrives, and the satellite pauses, resets, reboots into a known state, the way one might take a slow breath at a surprise and return to a familiar rhythm. Ground teams update tables. They upload fresh software, refined and carefully tested, the code arranged with quiet care, comments written like notes left on a tidy desk. The gentle rhythm continues. The journey of an aging satellite includes routine. Every week, there may be a station-keeping maneuver, a tiny correction that nudges its position back toward a slot where it will be where it has promised to be. In geostationary orbit, slight variations in Earth's geopotential pull a satellite northward and southward, eastward and westward, very slowly. Without corrections, it would drift away from its box, as operators call it, and neighboring satellites would edge uncomfortably close. So it performs inclination corrections and longitude adjustments, each one a tiny breath of fuel. The hydrazine or xenon in its tanks is finite, measured in kilograms, fluent enough to be spoken of as lifeblood, though we speak here in the softest of metaphors. Each puff is accounted for. The math is careful. The thrusters wake for only seconds at a time. The satellite steadies itself again. The gentle rhythm continues. Inside the bus, thermal blankets are not forever pristine. Micrometeoroids, bits the size of dust or sand, tap them no more loudly than an imagined fingertip touching a drum. These are not violent touches, only reminders that space holds traces of long histories. The blankets do their job even with tiny pinpricks, because their work is to reflect and to slow the flow of heat, a job that is forgiving of small imperfections. Sensors continue to read every time the calibration curves bend a little, and the ground software learns to bend with them, reading the numbers through a lens of experience. Engineers know the satellite's moods. When they see the graph of battery temperature rise slightly before a maneuver, they nod. When they see the beacon's strength dip at a certain angle of the sun, they nod again. The relationship is an old one, and it is comfortable. The payload does its work. Perhaps it relays calls, or carries data, or photographs cloud tops with a placid gaze. Perhaps it observes the dance of the ionosphere, or maps Earth's gravity with faint changes in orbit. Whatever its duty, it performs it not with drama, but with steadiness. Its amplifiers warm as they operate and cool when they rest. Its antennas point with patient exactness. In the early years, its output was a bit stronger, its noise a bit lower. In the later years, the difference is subtle but real, a slight softening at the edges of performance. Ground teams respond by adjusting schedules, narrowing beam shapes a bit, or compensating in signal processing like a listener leaning a little closer to catch a quiet voice. The gentle rhythm continues. Consider, as you drift, the way time acts on materials. Outgassing is a quiet exhalation, the slow departure of chemicals from varnishes and adhesives, molecules that choose space as their new home. As they leave, optical surfaces remain a little clearer. Electronics stay a little drier. Over many years, the rate of outgassing declines to almost nothing, the satellite settling into a mature state, like a book that has shed its printer's scent and now smells only faintly of paper and glue. The satellite has become what it will be for most of its life. The sun strokes it with the same light each day. The earth hides it with the same soft shadow in eclipse seasons. The computers count, the heaters warm, the radios speak, and the ground listens. There is a moment in every satellite's life when the budget of fuel, power, and purpose meets the arithmetic of decline. It is not a dramatic meeting, but a gentle one. Graphs that once showed comfortable margins now approach lines drawn as boundaries. The solar panels produce less, so the heaters are trimmed. The batteries hold a little less charge, so during eclipse the payload rests a bit sooner. The thrusters still work, but their budget of propellant is thinner, like the last pages of a notebook. Discussions on the ground become unhurried but thoughtful. There are meetings where people speak in low tones about trade-offs, extend a station-keeping interval to save fuel, and accept a small drift that can be corrected later. Reduce the power to a transponder by a single dB to keep thermal conditions gentle. Each choice is a kind of kindness, an act of caretaking to ease the work of an aging machine. Some satellites are designed to be flexible. They can switch to different bands, reconfigure their beams, use spare amplifiers that have waited for their turn for years. When a primary component grows tired, a backup wakes, a light turns on in a different rack, and the service continues. That wakefulness does not feel like a sudden change in temperament, but more like a careful rotation of duty in a watch. One guard stepping back while another takes the quiet walk along the parapet. Backups do not last forever, but they are part of the ledger, and each one lengthens the story. You may imagine now a morning in the control center when a decision is reached to begin the long glide toward retirement. there is no flourish. A manager nods. A planner prints a checklist that has napped in a drawer for years. The list is precise, built not for drama, but for safety and peace. It includes steps to move the satellite to a graveyard orbit if it is geostationary, a few hundred kilometers above the busy ring where active satellites keep their places. It includes steps to passivate the spacecraft, to vent propellant so it will not later burden the cold structure with pressure, to disconnect batteries in a way that leaves them safe and quiet. It includes messages to send to agencies that keep catalogs of orbital objects so the satellite's path can be expected and respected. The gentle rhythm continues. Before these final steps, there is a period of quiet heroism. The satellite continues to serve, but with the knowledge shared by all involved that its last assignments are underway. Perhaps a final experiment is run, where the payload tests a mode not used before, gathering data that will help future missions. Perhaps a final repositioning is performed, moving the satellite to a slightly different longitude where it can cover a special event or support a partner's network for a little while. Ground teams treat each action with the same care they showed on the first day. There is a feeling not of ending, but of completeness, like a chapter reaching its last paragraph, not rushed, not delayed, just arriving at the place where it was meant to arrive. On the day of the departure burn, the control room is as composed as ever. Commands are prepared with thoughtful redundancy. The satellite receives them in the calm light of the sun. It turns slowly, aligning itself to the vector that will lift it into the higher lane of the graveyard orbit. Thrusters open and close according to plan. Propellant moves through lines that have known its quiet pressure for years. Valves click. The burn is not long. It is an exhale. And when it ends, the numbers on the ground settle into new values. The satellite is now above the busy ring, slightly farther from Earth, where it will not drift back into someone else's slot. The gentle rhythm continues. Passivation is a word that invites calm. To passivate is to make passive, to remove the potentials that could awaken without invitation. Tanks are vented. Batteries are left in a state that will not tempt currents to surge. Some electronics are powered down. Others are left in a benign configuration so that if they wake, they will do nothing more than whisper and grow quiet again. Documents are updated. The object's catalog entry is adjusted. The control team sits back from the consoles a little, like a pianist lifting hands off keys after the final chord, letting the sound fade in the air. The satellite remains there, a patient object in a patient orbit. It still moves, as all things in space move, but without intent. Sunlight still touches it. Its panels still shine with a muted reflectivity. In some moments, a lens glints, because even a silent instrument can catch the light. The dark side still cools gently when the body turns. The vacuum keeps its counsel. The satellite becomes part of the gentle clutter of our civilization story, like a book placed quietly back on a shelf. Still awake? Comment the secret word, nebula. And now, imagine the years that follow. The satellite is quiet, perhaps not entirely silent. Metal still contracts and expands with heat and cold. If one were close enough and could listen with a sensor rather than an ear, one might detect faint signals of warmth moving or a wisp of outgassing from materials that still have something to share. But as time lengthens, the motion becomes purely orbital, the life purely inertial. The satellite is a point on a chart, one that catalogers include in regular updates, one that is respected in avoidance calculations by those who still navigate the busy lanes below. There is something peaceful in knowing it has a place where it does not interfere, where it is allowed to be simply a thing in the ski. If your mind begins to wander, you might drift back to earlier years and consider the moments that passed day by day. The sun rose on the satellite, and when it did, the array stirred into electrical life. The battery monitoring circuits took a quiet look around and smiled, if circuits can smile, at the incoming current. Heaters eased off. The computer noted time. The reaction wheels adjusted their speeds by the simplest of algorithms, nudging away the tiny torques that would otherwise have tilted the satellite's gaze. Antennas confirmed pointing by comparing the measured strength of known beacons. Commands were executed. Data was gathered. The ground station passed beneath, or if geostationary, the ground station simply looked up and saw the signal as faithful as the sunrise. If the spacecraft was low, it might have felt the faintest wisp of atmospheric drag even at altitudes where air would be called near vacuum on Earth. That drag was a promise that, in time, a low satellite would come back to Earth. But our aging traveler took the gentler path of the higher altitudes, where that promise could be postponed into harmlessness, and for geostationary satellites, redirected to a higher. Aging is not unkind. It is repetitive, and repetition is one of the most soothing things a mind can follow. The satellite turned solar energy into electricity, electricity into movement or signal, and movement into alignment. The orbit traced an ellipse that, to the human eye from the ground, would look like a still point or a patient glide. During equinox seasons, where eclipses are more frequent, the satellite prepared for shadows. It arranged its loads to avoid drawing too much power, while Earth's shadow passed over it. Ground teams compared eclipse predictions against power budgets and nodded at the margins. At the end of each eclipse, the arrays found the sun again and resumed the simple work of filling the batteries. The gentle rhythm continues. Years brought small changes to software. Versions incremented, not as a parade of features, but as a braid of refinements. If any hardware aged past specification, the software had ways to cope. It might recalibrate the star tracker to account for a slight bias, update current thresholds for heater control, or change the way the wheels were controlled to reduce vibrations at frequencies where a bearing felt more friction. On the ground, someone wrote a careful note in a logbook at the end of their shift. Another person wrote back in the morning, continuing the thread like a long correspondence that unfolds across years. There are satellites that fail suddenly, but we will set those aside and stay with our quiet elder that declines slowly, gracefully. This satellite has professional friends who watch it with affection. They prefer not to think of failure, but of completion. When a sensor grows noisy, they soften the way they read it, comparing it more often to its neighbors. When a transponder becomes less crisp, they narrow its workload so it can still do a subset of tasks with excellence. When the solar array has one string that opens circuit, they subtract it from the math and carry on. Nothing is wasted, but nothing is forced. The gentle rhythm continues. Every so often, the ground team plans a station-keeping maneuver. The plan is written down weeks in advance, and everyone knows exactly what each number means. They work out the amount of fuel, the duration of thrust, the direction in which to push, and the expected effect on the orbit. The satellite receives the commands at a time when its attitude is favorable, its vents pointed safely, its antennas aligned to maintain communication. When the moment arrives, the thruster opens. Hydrazine flows over a catalyst bed and decomposes, producing a hot gas that jets out into the vacuum, pushing the satellite in the opposite direction. A few seconds, and then the valve shuts, and the satellite continues on a slightly different path, like a boat that makes a slight correction of its rudder and finds itself back in the center of the river's calm. The fuel remaining is noted. The gentle rhythm continues. In quiet orbits, geometry becomes poetry. The sun sits in a nearly fixed place relative to the satellite's panels, and seasonal changes shift that position only slightly. Earth's albedo, the light reflected from clouds and oceans, washes over the satellite with a soft backlight. Infrared warmth from Earth balances the cold of space, changing by degree with the satellite's orientation. This balance is recorded in thermal models that agree with reality within a comfortable margin. Sometimes, when the sun is nearly behind Earth, the satellites in geostationary orbit experience an eclipse at midnight local time. During that window, the Earth's atmosphere glows faintly at the edge like a thin veil of firefly light. The satellite feels none of that glow as heat. It sees only the line in its power system where incoming current falls to zero. The batteries are ready, and they answer with no complaint. When the sun emerges again, the arrays contribute their measured light, and the cycle resumes. It is possible to imagine the satellite's quiet workload as music reduced to a single clear note. It is consistent, but not dull. It carries information. If you trace the current of electrons through its circuits, you would see pathways illuminated by purpose. They move from photovoltaic cells through diodes to bus lines, from bus lines through regulators to distribution panels, from there to payload electronics. Data moves on its own highways, from sensors through interfaces into memory, from memory packaged and encoded to transmitters that shape it into radio waves. The waves travel down through the ionosphere, through weather of electrons that occasionally scintillates and makes edges ripple, and then into the parabolic embrace of a ground antenna. Operators receive it, measure it, and route it onward. The loop is complete. The gentle rhythm continues. When the decision point arrives to begin the final drift, the work gains a ceremonial calm. There is a decommissioning plan that reads like a liturgy. Steps are performed in order, and each step is acknowledged. The satellite's payload is turned off in stages. Amplifiers are powered down and noted as safe. Heaters on certain assemblies are left on for a while to prevent thermal shock during the last maneuvers. The star trackers are used one last time to verify attitude before the thrusters fire. The tanks are warmed slightly, so pressures behave in predictable ways. The thrusters lift the orbit by a few tens or hundreds of kilometers as required by conventions and best practice. After the last burn, the satellite is allowed to drift in attitude to a safe, passive orientation. Propellant remaining is vented gently into space, leaving tank pressures near zero. Batteries are left in states that will not suffer from being forgotten. The final command is sent, and then silence becomes the proper language. In the quiet that follows, there is no sadness, in the technical sense. There is fittingness. The satellite has performed its function across years. Its decline into silence was planned, managed, eased. Futures are protected because the graveyard orbit keeps the highways clear for younger satellites who will begin their own rhythms. The people who cared for it turn to other tasks, still remembering it when graphs of power and orbit from those years serve as examples that teach new engineers what longevity looks like. A spacecraft is not a person. And yet, in the clean abstraction of engineering, there is the same respect one has when finishing a satisfying book and placing it gently on a shelf. Imagine now that you are floating very close to the quiet satellite. You see the sun reflected as a pale coin on a panel's sheen. You reach with your mind to touch a radiator panel that glows only in infrared, cool to anything your skin would guess. The Earth far below is half in light, half in dark, and the terminator line is soft, smeared by the thickness of air. You do not feel gravity, only a sense that the orbit cradles you, an invisible hand following a perfect curve. The satellite does not acknowledge you. It does not need to. Its last message is simplicity itself. Be still. If, as you drift here, you think of the factories where solar cells were made, and the laboratories where star trackers were calibrated, and the shipping crates where components rested before assembly, you can sense the breadth of quiet care that went into this machine. An industry that builds things to last decades has the same patience as gardeners of ancient trees. They expect winds and seasons. They plan for frost and drought. They build margins into strength and adjust them when the world changes. The gentle rhythm continues. You might picture a timeline from the day of concept to the day of silence. There are points on that line where small choices mattered. A connector orientation was reversed in a drawing, improving strain relief. A thermal interface material was switched to a more stable formula. A software routine began writing a checksum differently, and a later error was caught because of it. The orbit model was run with an extra equation for solar radiation pressure during eclipses, and a station-keeping fuel reserve grew by 1 comfortable kilogram. Choices like these accumulate into longevity. They become the slow story of an object that ages well. The language of orbit mechanics is sometimes austere, but here it can be gentle. Words like inclination and eccentricity and longitude of ascending node can be thought of as coordinates in a poem. Inclination says how far a path leans from the equator, like the tilt of a head listening. Eccentricity says how round or oval the path appears, like the difference between a circle drawn with a compass and an ellipse traced by hand. The longitude of the ascending node says where the path crosses a reference, like the point where you step off a porch and onto a garden path. Parameters shift with time under the influence of the sun and moon. The high orbits dance and sway a little under gravities. But this is a slow dance, measured in years and decades, more like the growth of a tree than the flight of a bird. Many satellites are not alone. They are members of constellations, even if each is situated in its own geostationary slot or its own sun-synchronous plane. The sky from Earth's surface is full of moving pinpricks that, with deliberate looking, reveal human presence in orbit. Some satellites speak with each other, cross-linking data so that messages travel not only up and down, but but sideways in the sky. Our aging satellite may have had neighbors that passed within polite distances, always coordinated by their caretakers to avoid undue closeness. Ground facilities keep watch with radars and telescopes. They publish conjunction notices that read like careful weather reports for objects that cannot feel the wind. If a maneuver is needed to avoid a potential approach, the teams plan it with the same unhurried care, moving their satellite by a tiny amount days in advance, so that the approach never becomes more than a number on a chart that grew smaller and then large again as the paths diverged. As you rest, you can let the details blur into the feeling of repetition. The cycles are nested like gentle waves. The satellite software cycles every second. The power system cycles through day and night across hours. The orbit cycles through precession across months. The mission cycles through seasons across years. The industry cycles through generations across decades. Each cycle refines the next, teaching lessons in a cadence that repeats without haste. The gentle rhythm continues. At the end of its service, the satellite's data archive remains. Telemetry is stored on servers with labels and dates. Researchers can revisit those numbers and see the gentle decline in solar current, the minute increase in battery internal resistance, the stable behavior of certain thermal nodes, the drift of a reaction wheel's bearing noise. Those curves can be compared with those from other satellites. Trends appear, and with them, improvements for future designs. The old satellite is a teacher even in retirement, not by speaking, but by the shape of its silence and the lines of its history. There may be a photograph or a rendering of the satellite from before launch, bright and tidied in a clean room. Engineers in hairnets and gloves stand near it, not touching, pointing and discussing. The lighting is even. The tools are neatly arranged. You can imagine the smell of fresh aluminum and faint solvents, the sensation of filtered air moving gently, the quiet attention in the eyes of the people working. They are not thinking about silence then. They are thinking about function. And yet, in the back of all projects that go to space, there is the understanding that the end of work is dormancy, and dormancy is not defeat. It is a normal part of the story. When the satellite enters its long sleep in the graveyard orbit, it becomes part of a larger sky. This sky is full of traces of our ambitions, our communications, our mapping of Earth, our weather watching, our scientific patience. It is not a dark cemetery, but a very remote attic where objects rest out of the way, undisturbed, bearing the marks of long service. If one could tour that attic, moving in a path above Earth's equator, one would see many such objects, each with a biography that overlaps with the others, each with its own gentle rhythm of data and power and timekeeping. The gentle rhythm continues. Imagine night on Earth beneath this ski. Ergonomic chairs are empty at the control center, screens dimmed, alert tones quieted. A maintenance team might be on shift, checking logs. Outside, the air is cool or warm depending on the season. Somewhere far away, under another sky, someone looks up and sees a point of light moving slowly and thinks for a moment about satellites. They might not know that above that horizon, a retired satellite drifts slightly higher than its lively cousins, content to be unattended. In a way, it is like an old lighthouse that still stands even after the harbor is closed, its glass intact, its stairs worn smooth by hundreds of rounds of the keeper's boots, its lamp removed, the lens still catching the sun in the afternoon and warming a patch of floor. rest with the thought that nothing about this story needs to be exciting. It is all patient cause and effect, measured, predicted, cared for. The people are as important as the machines, and the machines are as graceful as the math. And the math is as gentle as the orbit. When you close your eyes and breathe slowly, you can almost feel the velvety continuity of it, a continuous line that supports you and lets you relax. The satellite's slow decline is not like falling. It is like settling, like mist lowering onto a field in late evening, or like a murmured conversation drifting to an end when all the necessary words have been said. There are practical details that, even spoken softly, add texture. For instance, the geostationary ring sits over the equator at roughly 3576 kilometers above sea level. There, the satellite's orbital period matches Earth's rotation. The graveyard orbit is placed a little higher, with the exact altitude chosen with a formula that considers how solar and lunar gravities will disturb it over many years. Passivation procedures include de-energizing certain circuits in a sequence that avoids trapped energy in inductors and capacitors, and leaving safe discharge pathways. Bolts that were held in tension for deployment mechanisms remain forever engaged. Thermal straps that carried heat from electronics to radiators continue their silent conduction. Multi-layer insulation made from alternating thin sheets still catches and reflects the sun's heat. The gentle rhythm continues, and there are intangible details as well. A mission patch, perhaps, designed at the start with a small, simple emblem. Engineers' names on a plaque near the clean room door. A binder of procedures, its edges worn smooth by thousands of quick turns. A coffee mug left as a joke next to the rack where test instruments are kept, labeled Flight Spare. A memory of the first acquisition of signal after separation, when the first beacon was seen, not with a shout, but with a nod and a half-hidden smile. The texture of these things stays in the minds of those who were there. The spacecraft itself, moving far above, contains none of these human traces. It contains only the physical traces of its work. But the combination of the human and the mechanistic forms a full picture. If you listen to your breathing now, slow and even, and let the picture of the satellite drift across your inner view, you might notice the repeating phrase of this narration, a gentle refrain. The gentle rhythm continues. That is not by accident. The mind rests when it knows what comes next. It allows details to pass by like scenery outside a window. You do not have to gather all of them. You can let them approach you like soft waves and let them recede in the same gentle way. The satellite's slow decline is like that. Even the final silence is a continuation in another register, a shift from sound to the breath that existed behind the sound all along. Think of the instruments that measured pointing using stars. Star trackers take small images of the sky and compare them to onboard catalogs. They do not need to know stories of constellations. They need only the angles between points, the measured brightnesses, the distances between familiar patterns. From those comparisons, they tell the satellite how it is oriented, and they do so with extraordinary precision. Over time, hot pixels might appear in their detectors, small points that the software learns to ignore. A little more warmth in the electronics might prompt a recalibration. The tracker continues, faithful through years. The reaction wheels use these measurements to spin up or down by minute increments, adjusting attitude so that antenna beams stay pointed and radiators face the cold. The gentle rhythm continues. The radio system is, in its essence, the art of shaping and catching waves. Frequencies are chosen to travel through the ionosphere with acceptable refraction and absorption. Bands have regulations and customs. The satellite was assigned its use before it left Earth. For years, it abided by that assignment. When it was active, its downlink carriers were steady lines in a spectrum analyzer's display. Their purity was a matter of pride, their sidebands tidy. In the last weeks of operation, teams took note of any small increase in noise, any drift in the exact frequency. They were not worried. They were curious, learning as much as they could. And then the transmitters were powered off, and the analyzer showed only the background. The absence was informative in its own way, a kind of exhale. There were also, perhaps, maneuvers at the start of life that set the spin of the solar arrays to minimize shadowing. Depending on design, the arrays might have been fixed or articulated. Fixed arrays are simple and last like good sandals, but articulated arrays can place themselves for better light, turning slowly to face the star. The motors in these gimbals are designed for thousands of cycles. The bearings are chosen for vacuum and temperature. Their grease is not grease as we think of it at a kitchen table, but a film that does not outgas easily. After many years, the torque to turn them increases slightly. The controllers notice and ease the acceleration to keep them comfortable. It is the engineering equivalent of carrying a heavy object with both hands instead of one. The gentle rhythm continues. In the structure itself, the aluminum honeycomb provides stiffness without mass. It is a sandwich, thin face sheets bonded to a core with hexagonal cells. This geometry resists bending with grace. Embedded inserts tie brackets and components to the faces in places chosen to avoid stress concentrations. The result is a body that holds its shape through thermal cycles and through the quiet pushes of thrusters. It is a body designed not to surprise anyone, not to warp or crack or fatigue suddenly. The adhesives that hold it together age with exposure to radiation and temperature, but their change is small and accounted for. Engineers tested samples in chambers where lamps mimic sunlight and cold plates mimic night. The results informed margins. The satellite benefited from this quiet testing all through its life. If you picture Earth now from the satellite's altitude, you will see it as a whole. Clouds arrange themselves, weather fronts curl like brush strokes. Oceans show subtle changes in color where plankton bloom or sediment spreads. Cities glow in faint wisps at night. Lightning flickers in the tops of storms, a silent ballet on the dark side of the world. The satellite, if it was meant for communications, relayed signals that passed through some of those cities. If it was meant for imaging, it took pictures of some of those storms. It was involved, without ever having to know anything, in human life below. Its slow decline did not change that. Its retirement is simply the closing of a connection. The gentle rhythm continues. Data about the end of life is recorded carefully. The final delta V used for the graveyard maneuver is listed, the final propellant mass estimated, the final battery state of charge measured, the final switch positions noted. These become the epilogue of the spacecraft's official biography, not written in paragraphs, but in lines of telemetry and in careful annotations. The team reads the last lines and signs their names or initials, indicating that the steps were taken according to plan. The satellite's page in an internal system is marked as retired. It is a quiet ceremony, often conducted by a keyboard and mouse. The culture of spaceflight includes respect for debris mitigation. The graveyard orbit is part of that culture. So is the removal of energy sources that could cause unexpected activity. The point of all this is to leave a safe sky. It is a long-term view, the kind that suits people who think in orbits. The gentle rhythm continues. As you sink deeper into this gentle narration, notice how your own orbit of thought repeats. You return to the image of the satellite gliding. You add a detail or two, then you drift away to something nearer, like the sound of your breath, the feel of your pillow. Then you return to the satellite without effort. The mind likes to circle, and circles are soothing. The satellite's circle around Earth mirrors the circle of your attention around the idea of rest. Each time you come back, you can let go a little more. As if setting a small weight down on a shelf, you can reach without looking. Some satellites, when retired, are photographed by others. A newer satellite passes nearby and takes a grainy image that shows nothing more than a small, elongated shape with two arms. The image is not dramatic. It is a reminder. Things we make go into the sky and remain there in some form for a long time. We are not alone in that sky, but we are careful about sharing it. The retired satellite is not a hazard. It has been placed where it will not intrude. The picture of it is like a snapshot of an old house from a train window. The train does not stop. It is enough to have seen. Think again of the ground, where antennas sweep slowly. The motors in those pedestals are themselves items of quiet engineering, turning dishes that weigh tons with precision measured in fractions of a degree. Lubricants in their gears are chosen for cold nights and warm days. Their enclosures keep out rain and dust. Their encoders report angle with whispered fidelity. Operators schedule maintenance, climb ladders with careful steps, take measurements, adjust. The link to the satellite was held by such machines for years, each day like the previous, each week a careful repetition of calibrations and checks. When the satellite was retired, the ground equipment carried on with others, because the sky is full of tasks. The gentle rhythm continues. Inside the satellite's memory, there may have been an error counter that incremented each time a particular bit needed correcting. That counter rose slowly at first, then more quickly toward the end, a reminder of accumulated radiation. This did not cause panic. It caused attention. The count was noted. Strategies were adjusted. Single event upsets are life in orbit. They are like gusts of wind at sea, not storms to be feared, but breezes to be accounted for in the sail trim. In retirement, the counter is frozen. The numbers are now a marker at the end of a trail, letting those who follow understand how the journey went. If the satellite had cameras, they may have been switched off early. Detectors can be sensitive to light or to temperature in ways that do not favor indefinite operation. If it had scientific instruments, they will perhaps run one last time to gather calibration data at the end of life. The shapes of their graphs, their baselines, and noise floors are instructive. Such data can be comforting to researchers who believe in slow learning. The satellite contributes to understanding even in the moments before it goes quiet. There is, in all of this, a quiet bridge between the grandness of space and the intimacy of rest. Space is vast, and yet the story at this moment is small. It is one object, one set of systems, one set of decisions, and one final set of steps that lead to stillness. The mind can hold this and find it soothing. The gentle rhythm continues. Imagine now that the satellite is nearly invisible in the dark. Only a faint glint betrays its presence when the sun catches the edge of a solar panel. If someone on Earth were to look up with a telescope at just the right time, they might catch that glint, and even without knowing this particular satellite, sense the age and the slight irregularity of the flash. That irregularity could be simply the rotation of a body that is no longer carefully controlled. It could be a minor tilt that was never corrected after passivation. It is not harmful. It is only an imprint of the end of service, like a slight fade in a well-worn fabric where hands have rested. The sky will accept other satellites in time. Another spacecraft will be planned, built, and launched. It will carry a new mission, perhaps taking on tasks that the old satellite once did. But with improved instruments, better efficiency, more robust error correction, more thoughtful passivation plans, and it will begin its own gentle rhythm. None of this urgency touches your rest. It is enough to know that others will continue the work, and that those who care about such things have long horizons. The long decline from service to silence can be thought of as a drift, a word that suggests motion without tension. The drift is not a loss. It is the natural continuation of an arc. The satellite was always going to leave its service orbit at the end, always going to silence its radios, always going to become a quiet shape under the sun. People guided it along that path with care and kindness. You, listening, now can accept that path as simple and believe in its ease. When your mind returns to your room, bring back with it the calmness you felt at the edge of that orbit. The walls are steady. The air is gentle. Your pillow supports you like the ark supports the satellite. There is no schedule you must keep in this moment. There is no station-keeping maneuver needed in your thoughts. There is only the slow balancing of breath in and out, like the day and night cycles of power on that distant machine. The gentle rhythm continues. If you find sleep arriving, let it come like the slow shift into shadow during an eclipse, a change that requires no action from you. If you stay awake a while longer, rest in the image of the graveyard orbit, a lane set aside for rest, a place where the rules are designed for minimal interaction and maximum calm. The satellite is not lonely there. It is part of a pattern. You are not alone here either. You are connected to a pattern of others who listen and rest in the same calm way. Hidden within the calm of the satellite's retirement is a reminder of stewardship. The people who placed it in a safe orbit were thinking of those who will come after. That thought is a kindness extended forward. You can mirror that kindness to yourself by planning small things that ease your next day. Leave a glass of water within reach. Set an alarm to a soft tone. Arrange what you will need in the morning so that you can wake without hurry. The space industry's respect for future missions can be a model for your own respect for your future self. The gentle rhythm continues. The sensors on the satellite, now unpowered, are like senses folded in rest. The gyros no longer measure spin, the star trackers no longer look. The radio no longer glows with the faint warmth of transmit power. The batteries no longer balance charge and discharge. The structural elements no longer feel the small muscle of reaction wheels resisting a solar torque. And yet, in the inertial frame, the satellite keeps its orientation a while, then slowly shifts as forces imperceptible build and release. Everything is slow now, slower than any urgency, slower than any thought. It is a pace that suits sleep. In this last stretch, return to the first image, the satellite gliding, an elder traveling the same path that it has known for years, now released from duty, held by the same physics that once supported its work. Physics that is constant and predictable and friendly in its reliability. The sun shines. The Earth turns. The orbit persists. The satellite changes from active to passive, from voice to presence. The gentle rhythm continues. You are comfortable, breathing softly. The lights outside your window might dim or shine, as they always do. The fabric of your blanket is simple and reassuring. Somewhere above, in a region of space where pressure is measured in nothingness and temperature is a matter of what is touched by sunlight, a quiet artifact keeps a place that was planned for it, safe and calm. There is no need for a conclusion more complex than that. It is enough to know that the story had a beginning, a long middle, and a peaceful end. Thank you for keeping me company in this calm exploration. As you drift now, rest in the certainty that the skies are cared for, and that even the most technical of stories can end with gentle ease. Sleep well, feel safe, and when you wake, if this gentle vibe helped you unwind, you can subscribe and leave a like so we can keep releasing soothing videos this often. The gentle rhythm continues, and you are welcome to let go into it now.